Hello students, in our today's lecture we are going to discuss about light and its properties, reflection, refraction, dispersion and different aspects of image formation. These topics we are going to cover in today's lecture. So before starting our lecture, first topic is reflection of light. So what is this reflection of light? So here reflection is the phenomena of bouncing back of the light into the same medium and striking the surface of any object. For example, you assume this is the plane. If the light is striking this surface and the ray will be reflected back like this. So this is known as a reflection. This property is known as reflection. So if you assume this is medium 1 and assume this is medium 2. So the phenomena of bouncing back of light into the same medium and striking the surface of any object is known as reflection. This is known as reflection. So to understand this reflection, we will analyze what are the laws of reflection. So first law is incident ray. Here you need to understand some things. This is known as incident ray. And this is known as reflected ray and incident ray. So if you draw a particular normal like this, the incident ray normal to the surface at the point of incidence and the reflected ray all lie in the same plane. That is the first law of reflection. So this entire part will lie in a particular plane. So the plane they won't deviate from a particular plane. And what is the second law is the angle of reflection is always equal to the angle of incidence. So I and incident angle and reflected angle both will be same. This is known as angle of incidence and this is known as angle of reflection. So what is the angle made by the incident ray with the normal and what is the angle made by the reflected ray with the normal? These are known as the incident angle and reflected angle. They both will be equal to each other. And in this topic we are going to discuss about the formation of images. So you all know about the plane mirror. So how the images will be formed, what is the property of the particular image, what is the size of the image and where the image is going to form, and whether it is an inverted image, it is a real image or it is erected, like that different aspects we are going to understand in today's lecture. So before understanding all these aspects, here we are having a theory about the spherical mirrors. So if you analyze, we are having two different types of spherical mirrors. So plane mirror is one thing and here we are discussing about the spherical mirrors. So here convex mirror or diverging mirrors are one type and concave mirror or converging mirrors are another type. So if you say for incident ray is falling like this, it is known as concave. So if the mirror is like this and incident ray is falling like this type of mirror is known as the convex mirror and this type of mirror is known as the concave mirror. So if you observe, convex mirrors are diverging mirrors in which reflecting surface is curved outward. So this is convex. This is convex. It is curved outward. And concave mirrors, these are the converging mirrors in which reflecting surface is curved inside. So some terms we need to understand in about these two mirrors. So what is the center of curvature? What is the radius of curvature? What is the pole? What is the principal axis? What is focus? These nomenclature you need to understand. Okay. So one by one we understand what is the center of curvature. If you observe these spherical mirrors, you can assume they are part of a sphere. So you are cutting one particular part in a particular sphere. So for example, you are cutting like this, it is becoming, so if this is the sphere, you are cutting like this become a convex mirror. So if you are cutting like this, if this is the part, it is becoming a concave mirror. So if that is the assumption, what is the center of that particular part, center part of the sphere from where you cut that mirror, that gives the center of curvature of that particular mirror. So you are going to assume, for example, this is the mirror part. So here you can assume this is going to be the center of curvature. With this radius you can draw a particular sphere, and this becomes the center of curvature for the particular mirror if it is a concave mirror. Similar way we can show the point for the convex mirror also. Now what is the radius of curvature? Radius of a curvature of a spherical mirror is the radius of the hollow sphere of glass of which the spherical mirror is part. So this length is nothing but the radius. This point is center of curvature and this length is known as the radius of curvature, and it is represented by capital R. Now what is pole? Pole of a spherical mirror is the center of the mirror. So if you observe, this particular point is known as pole. For the mirror where you are getting the center point, that is known as the pole of the mirror. Now what is the principal axis of a spherical mirror is? This is the principal axis of the spherical mirror. So what is that? It is a straight line passing through the center of curvature and the pole of the spherical mirror. This is known as the principal axis of the spherical mirror. Now what is the focus? Focus of a concave mirror. Now I have drawn a concave mirror here. You can see. So for this particular concave mirror, if you assume that if the light is passing like this, the rays of light are falling on the mirror parallel to the principal axis, where they are going to meet, that particular point is known as the focus. So it is a point on the principal axis at which the rays of light incident on the mirror in a direction parallel to the principal axis actually meet after reflection. That particular point is known as the focus point, focus. Now what is the principal focus for the convex mirror? If you assume a convex mirror, it is the convex mirror. It is a point on the principal axis from which the rays of light incident on the mirror in a direction parallel to the principal axis appear to diverge after reflection from the mirror. So where they are going to diverge. So in the concave mirror they are going to converge, and if it is a convex mirror they are going to diverge. So if you extend the diverged rays, where they are going to meet, that will become the focus point. So that is the difference between the concave mirror and the convex mirror. So what is the focal length? Focal length of a mirror is the distance between the pole and the principal focus. So just now we discussed about the focus, right, where they are going to meet. So the distance between pole and focus is nothing but the focal length. This becomes the focal length for the convex mirror. If it is a concave mirror, if you see here, they are going to, this is the principal axis, so they are going to converge like this, and this is the focal point, and the distance between the focal point and the principal point, this is known as focal length. Okay, focal length is small f, it is always r is equal to 2 times the focal distance.